One of the first things you will encounter when learning Python is the concept of variables, a simple yet powerful way to store and work with information in your programs. Imagine you are in a kitchen. In front of you are a few neatly labeled containers. One says sugar, another says flour, and the third says salt. You don't think about the ingredients inside each time. You just use the label to grab what you need. This is exactly how variables work in Python. A variable is like a labeled container that holds a piece of information for you, whether that's a number, a word, or something else entirely. In Python, creating one of these containers is incredibly easy. You simply give your variable a name, use an equal sign, and assign it a value. For example, you can write name equals Alice. That means you have created a variable called name and it's holding the string Alice. You can do the same with numbers like age equals 25, for example, or decimal values like height equals 5.6, or even booleans, true or false values like is student true. What makes Python especially friendly for beginners is that it automatically understands the type of data you are assigning to a variable. You don't need to tell Python, hey, this is a string or this is a number. It just knows. This flexibility is what we call dynamic typing. Once you have created a variable, you can use it throughout your code. If you print name, for example, let me do that. Print name and run this cell, Python will return Alice. If you later change name to Bob and print it again, Python will now return Bob. Let's do that. Name equals Bob. Now let's print name. So the label stays the same, but what's inside the container has changed. Variables can also be used together. For example, let's say you are writing a recipe. You define cups of flour as a variable that holds a value of 2. Another variable as cups of sugar, which holds a value of 1.5. The total cups variable equals cups of flour plus cups of sugar. So if you print the value of total cups, it will do the math for you. Just like in your kitchen, it's about combining what you have to get what you need. So total cups equals cups of flour plus cups of sugar. 2 plus 1.5, that makes 3.5. You can also perform more complex operations. Let's say you want to calculate the area of a rectangle. For the area of the rectangle, you need to have the length of the rectangle and its width. So let's do that. Let's say that the length of this rectangle is 10 and the width is 4. The area is length times width. If you print that, print area, that will give you 40. You can also make it more fancy, like print the area is area. So this will output the area is 40 because the variable area is length times width, which is 10 times 4, and it gives you 40. This shows how variables can be combined and reused to perform real-world tasks. Now about naming your containers, your variables. There are a few rules in Python. Variable names must start with a letter or an underscore. They can include numbers and underscores, but not spaces or hyphens. And they cannot use any of Python's built-in keywords like if, class, or while. It's also best to choose names that clearly describes what the variable holds. Something like total price, let me do that, total underscore price equals 40. That is much better than x equals 40 because this variable total price is more descriptive and it gives you enough information to understand what this is. Let me provide you with some good and bad examples about variable naming. So here are some good examples and bad examples. For example, student underscore name, that's a good example. It is descriptive and it gives you enough information to understand what this is. Average underscore score is, again, this is a good example. Some bad examples. Too cool for school, it's a bad example because it starts with a number. My hyphen variable, it is also a bad example because it contains a hyphen. Class equals physics, it's also a bad example because this variable uses a reserved keyword. Another thing to keep in mind, Python variables are flexible. If you start with, let's say, value equals 10, and later decide to change it to value equals 10, Python won't complain. It will just update the value and its type. But be careful. Changing a variable's type midway through a program can lead to unexpected results. To help you keep track of what a variable is storing, Python has a built-in function called type. You can use it to check the data type of any variable. For example, let's say that you have a variable x, which is not a good naming, but let's for now keep it as x, and the value of this variable is 42, and let's print the type of this variable. So the output will be class end. Let's try that. So that is the output. So basically it provides you with the type of the data that is stored in this variable. And if you ever need to change the type, for example, converting the string into the number, you can use typecasting functions like integer, float, or string. Let me do a text cell. For example, if you have a variable called as price and its value is 100, so this is a strange variable, you can convert it to integer by doing price equals integer price. Now you can use it in calculations. So the first variable, this strange variable, you cannot use it in calculations because this is a text. But the second value, which is converted of this value, this is an integer value, and you can use it in calculations. Let's wrap this up with a simple real-world example. Imagine you are a baker tracking ingredients. You have a variable called ingredient and the value of this is sugar. You have this sugar as an ingredient and another variable as amount, which is 2.5, and unit of this variable in cups. Now suppose you want to double the amount. You can do it by just having this line of code, amount times 2. You can now print amount, and now the amount is 5. So the new amount is 2 times the initial amount, which is 5. So you have just updated the variable's value. This is the beauty of variables. They allow you to store, retrieve, and update information easily and meaningfully. Next, we will explore the different types of data you can store inside these containers, like strings, integers, floats, and booleans, and look at how Python recognizes and handles each one behind the scenes. Strings are sequences of characters used to represent text. You define a string by placing text inside single or double quotes, like, for example, let me define a variable greeting hello. This is a string, or another variable program, the value is Python. All these are strings. Integers are whole numbers without any decimal part. For example, let's say age equals 5, or temperature equals minus 27, or another one, year equals 2025. These are all integers. Floats are numbers that contain decimal points, like length equals 0.567, or another one, pressure equals, let's say, minus 56.8. So these variables are useful when you need more precision in calculations. Booleans represent truth values and can only be either true or false. These are often used in decision making and logic. For example, let me do a Boolean variable is valid, true, is student, false. These are Boolean variables. Python automatically identifies the data type when you assign a value to a variable. You can check the type using the type function. Let me give you some examples. So in this example, the first variable is name and its value is Alice. It is a string. The second variable is age and it is an integer. So if you print the type of this variable, the first variable, it will give you a string. If you print the type of second variable, it will give you the type as integer. The third variable, price, is float, and the value of is 19.99. So the class is float. The first variable is a Boolean variable and the value is true. So let's run this cell and you see that the type of the first variable is string, the second one is integer, the third one is float, and the first one is Boolean. You can also hover over these variables and it will give you the type of variable. For example, the first one is a string, second one is integer, third one is float, and the third one is Boolean. It also provides you with the value of each of those variables. So to recap, variables in Python are like labeled containers. They store data, they are easy to use, and they make your code more readable and manageable. Mastering them is the first step toward writing useful programs.